Two.
Hi guys, my name is Becca. I'm a senior in Allenstown High School and a student in STEM. This year my project is endocrine disruptors on bladder extrophy. Just to brief you, I didn't want to include any pictures because it's graphic and not everyone is super great with blood and gore and stuff. So what is bladder extrophy? Bladder extrophy is a urogenital malformation where while the baby is developing in the womb, the bladder doesn't close and the skin over it doesn't close either. So when the baby's born, the bladder is open and outside the body. So if you can just imagine this part of your skin not being there and your bladder being a little bit raw. It happens in about 1 in every 40,000. The statistics change every year. It started a while ago with like 1 in every 100,000. Some people say 1 in every 60,000. But point is, it's rare. And it is more common in boys than girls. There's a 2 to 3 ratio. What are endocrine disruptors? Endocrine disruptors are exactly what they sound like. They're chemical, I can call them chemicals. They're chemicals that are either in our water, they come from burning plastics or fertilizers, and they're impurities that will latch on to our endocrine receptors and either fake as a legitimate hormone or substitute for it or add to it, and they're not good. They disrupt our endocrine system, so never good. I'll do my hypothesis first. My hypothesis is that if an area has a lot of endocrine disruptors, there will be more occurrences of bladder extrophy. These are my mentors. Why do I think that? There's been a lot of research conducted on hypospadias, which often goes hand in hand with bladder extrophy. It only happens in boys. It's when the penis is underdeveloped and the urethra isn't at the tip of the penis, rather it's somewhere on the, what's the technical term? It's higher up, it's not at the tip. So because of that, oftentimes it's connected to bladder extrophy. Sometimes boys born with bladder extrophy, he suffers from hypospadias too. So there's a ton of research on hypospadias. And according to research, the closest thing to a cause that they found is that things in our environment, so endocrine disruptors, cause hypospadias, and there are impurities while in the air, in the water, while the mother is pregnant. The baby can be born with hypospadias. So also there is a bunch of evidence that endocrine disruptors cause polycystic ovaries and a ton of stuff within the urogenital tract. So it's reasonable to think that it can be a cause of bladder extrophy. So my research protocol, we have my hypothesis. So I worked on this project last year, but I think the thing that I understand this year that maybe I didn't understand last year, it's not a project of causation. The only way that I can absolutely say this causes this is if I test it. And there's no way to test humans. I'm not going to fill pregnant mothers with endocrine disruptors. So it's a correlation study. So I have information from the CDC that lists the amount of different diseases or abnormalities, bladder extrophy being one of them, for the last 4 years for all 50 states. And the idea is that a state that has more endocrine disruptors will have more occurrences of bladder extrophy. So I'm correlating. If this is this, then I look at this, and if it makes sense, then I can say, hey, maybe this is a possibility. So I'll use an atrazine test kit that I had last year, which is an assay kit. I didn't go through that whole procedure, but basically the way it works, they give you certain solutions that are certain parts per billion atrazine, and you put those in the spectrophotometer and see the absorbance, and then compare that to your samples. So if you know this is like 3 parts per billion atrazine and it has this absorbance, then your sample, if it's whatever, might be close to the absorbance or 3 parts per billion or 5 parts per billion, and that's sort of how an assay kit works. Just a general schedule. I would like to order all of my additional test kits between now and the beginning of October, so that I can analyze my data by the end of November, hopefully over winter break, and that's going to be the majority of my project, is analyzing the data that I have. My procedure, my procedure is super generic because I'm going to be sending my water off, and I don't know their procedure, but once I do, I'll tell you. So pretty much I collect water. So I have water, I got water from California, by the way. California, Texas, Colorado, Illinois. And from Illinois, I have Chicago, Taylorville, and Skokie. Then I'll test the water for atrazine, bisphenol, fluoride, and glycol ethers. Why did I pick these? They're very common in water, number one. Number two, they've all been associated with some type of urogenital malformation, whether it's like polycystic ovaries, like I mentioned before. And fluoride is something that we know is in our water, and that they put in our water that is still considered an endocrine disruptor. So I'm kind of using that as my constant, because I know it's not going to affect the urogenital tract. So I kind of have it as a constant that these are the levels of fluoride and compare that to the levels of everything else. So hopefully the way it'll work out is that one will sort of stand out. So there will be like certain amounts of atrazine, for example, and bisphenol, but the amount of glycol ethers will stand out from the rest. Then I'll compare the amounts of endocrine disruptors in every state. So I'll have all of those, in a spreadsheet, and I'll understand how much of what is in every state, or in every water sample, rather, and then correlate those to the CDC information about the occurrence of extrophy. So hopefully the way it'll work is that maybe if I have a ton of glycol ethers, I'll also have a lot of occurrences of bladder extrophy. And if it doesn't work, that's okay too, because then we can knock these and be like, okay, we know it's not these. Let's move on. Also, though, I have my scientitis, I don't know what you call it, my technical procedure, which is the stuff I have to do, but there's stuff I have to learn as well before conducting my experiment and during conducting my experiment. So I have to understand the normal versus an extrophy baby. So I have to understand the embryology of a normal baby. So far I understand that whatever goes wrong happens between like the 10th and 14th week of gestation. And I have to understand the difference in hormones. Is there a difference in hormones? Because what I've read so far is that everything about an extrophy baby is absolutely normal, except for the fact that their bladder is outside of their body. But my hope, I guess not hope, kind of hope, is that there is a difference in the hormones of an extrophy baby and a normal baby, because that would kind of support my hypothesis. So I made an appointment with my mentor at Erie Children's, just so, because I'm sure they've run blood tests on babies before who were just born with extrophy, so hopefully there's something that stands out. And I have to understand what exactly goes wrong. So what exact hormones are involved in the development of the urogenital tract, and what endocrine disruptors substitute for this hormone. So my variables, my dependent variables are bisphenol, atrazine, glycol ethers. My independent variable is the occurrence of extrophy, and my control is the fluoride that I know is in water and that I'll test for. So like I said, I worked on this project last year. So far I've tested for atrazine in 7 different water samples, and I'm going to run another trial as well as send off water to test for other endocrine disruptors like bisphenol, glycol ethers. Glycol ethers is the one that's associated with shrunken testes, and fluoride is my constant. My learning outcomes. So I didn't really know, I wasn't quite sure what to say for this. I know I didn't use a spectrophotometer. It was hard. This is the hard way. We struggled with that one. I'll learn how to go through a lot of data and correlate it. I'll learn how to statistically analyze data with the help of Ms. France, our statistics teacher. I learned how to conduct an assay kit. And I will learn how to advance my technology skills. I'm not quite sure if that's true, but I'm pretty sure I'm going to have to use some kind of program to statistically analyze my data. So what? Bladder atrophy occurs in 1 in every 40,000 live births. And even though it's rare, it deserves attention because pediatric research as well as research for women is severely underfunded. Research is a very male-dominated field, I'd say, so I think that's kind of something that attracted me to doing this project. Also, because it's personal to me, because I was born with bladder atrophy, but even when I tried to do research for myself in understanding, okay, what are my chances of carrying a baby and things like that, there's so little research on women who were born with atrophy. I can find a ton on guys, but that doesn't help me. So I think, yes, it's personal, but at the same time, it just ties back to this thing that not everything gets the research it deserves and the attention it deserves, and I hope that I can give something some attention. These are just my sources. Sorry, I got cut off